There are certain characteristics about quadratics, and these can be split up into different conic sections. And today, we're going to be talking about the equations of parabolas. And we'll kind of move through this unit looking at the different type of quadratics that you could potentially have, such as a parabola, a circle, an ellipse, a hyperbola. I mean, all of those different things. But specifically, we're going to be looking at parabolas. So a parabola, which this is probably the most familiar quadratic, is in the form like this. And this is why I say it's the most common one that most people know. It's because it's what most people have seen based on like x squared plus 4 and all of that good information. So we need to talk about the characteristics and what each thing is. So to start off with, mine's not very centered, I'm sorry. This is what we know as the vertex. And we've talked about this in the sense that this is either a relative min or max. But with a parabola, this is what we call our vertex. And this is h comma k. And that'll make a little bit more sense when we get to the actual equation. Then we have our direct line. So technically we have a vertical line that goes through our vertex. Then we have a direct line. A direct line is directly tied to the focus, which I haven't quite told you what that is yet. We'll have a point up here, which will be called our focus. So let's figure out what those actually are. So by definition, a parabola is a set of all points that are the same distance from the focus and direct line. So what this means, any point that I pick on this parabola is going to be the same distance from the focus and the direct line. So obviously based on my picture here, it's not actually the same, but when we figure this out algebraically, it will be the same exact distance. Okay. So we've got our directs, we got our focus, we have our vertex, and we'll also talk about our direction of the opening. We'll talk about the axis of symmetry, which is pretty basic. And then we'll also talk about the latus rectum, which goes through our focus. This is a line segment from the focus of the parabola and perpendicular to the axis of symmetry. And if you notice, the axis of symmetry is the line that's vertical going through the vertex. All right, so great. We got all these definitions and all of these characteristics. How does this help us? This helps us in order to graph our parabola. This also gives us an idea of what the parabola looks like before we even graph it. So with that being said, how do we calculate this information from our parabola? So if your parabola is going to be split into two different options here, and that's based on whether it's a y equals or an x equals. If it's a y equals, it'll be in the form of a x minus h squared plus k. And it could be in the form of x equals a y minus k squared plus h. So our axis of symmetry is x equals h. And that's because if we have y equals, that means we have a right side up parabola or a downside parabola. So we need a vertical line, which is why we have an x. If you have an x equals, this is a sideways parabola. So we know that we're going to have a y equals. So it needs to be a vertical line. Okay, so that's our axis of symmetry. Our vertex. This one doesn't change for either one. It's h comma k. Notice that if you are inside the parentheses, the sign would switch. So if you look at the y equals one, it's a negative h, but it comes out of the vertex as a positive h. The k stayed the same. The focus can be found from h comma k plus 1 over 4a. At the same time, this one just kind of flips. So it's h plus 1 over 4a, comma k. For the direct line, the direct line can be formed from that k, except this time it's minus 4a. For the x equals 1, it's x equals k, sorry, not k, h minus 1 over 4a. Direction of the opening. This just tells us whether it opens up or down. If it's up, it's a positive a. If it's down, it's a negative a. If it's to the right, this is going to be a positive a. If it's to the left, it's a negative a. And last but not least is our lattice. This is the length. And this is the absolute value of 1 over a. And it actually doesn't change for the other one. All right. So based on this information, we're going to start off with, and we're going to go through and figure out all of that different information. I know this is a lengthy video. I'm sorry. We actually will still have more stuff to do in class. So let's say, for instance, that I have my equation is in the form of y equals 1/2 x plus 12 squared minus 80. So basically what I want you to do is to fill out that chart. So the first thing, I always just go right down the chart. I do list out what A is, what H is, and what K is, just to make it a little bit easier when I'm filling that information out. A in this case is a 1/2. H is a negative 12. K is a negative 80. So notice H was inside the parentheses, so it came out as a negative, but the negative 80 was outside the parentheses, so that sign didn't change. So the axis of symmetry is going to be at x equals h, so that's x equals negative 12. The vertex is at h comma k, which would give us negative 12, negative 80. The focus is in the form of h comma k plus 1 over 4a. So we'd have negative 12 comma negative 80 plus 1 over 4 times a half. So I really want you to actually simplify that. So it's negative 12, and then it would be negative 80 plus a half. So that'd be negative 79.5. The directs is that y equals k minus 1 over 4a. So y equals negative 80 minus 1 over 4 times a half. So we'd actually have then y equals, so it'd be negative 80 minus a half, so it'd be negative 80.5. Direction we have our a value is a positive 1 over 2. So this means that we are going up. And our length of our lattice rectum is 1 over a. So that's really the absolute value of it too, sorry. So it's really 1 over a half, which we know is 2. So all of this information is to help us with the graph. There are different ways in order to show this. The other thing is your equation will not always be in this form. You might have to rearrange it in order to get it in that form, which is what we will actually be doing in class.